350 Pontiac. I've got the connecting rods out of the steel abrader. They've been shot blasted and cleaned so that we can get a better look at them and start working on them. On this connecting rod that spun the bearing, before we go ahead and press in our ARP bolts and do any actual machining on it, I want to actually measure it up and see how bad it really is. So I'm going to put the original stock bolts back in and we're going to measure it and see how it comes out.
Being a nearly stock rebuild, we don't need performance rod bolts, but none of our suppliers had a stock set available and we don't want to reuse the original bolts.
So I've got an old bearing catalog here and I've looked up for the connecting rod bearing in a 350 Pontiac. The correct OD of the rod bore is 2.3745 to 2.3750. So what I'm going to do here is I have our mic set up to that smaller dimension, and we'll basically get this set on zero there. It's kind of tough to do with one hand. Our housing bore of our connecting rod can be up to 5 marks past the 0 point on this gauge. But my preference is to keep it a little bit on the tighter side, so I'll try to shoot for 2 to 3 tenths past the minimum spec. Now, this is what we expect to see with the connecting rod that has had the rod bearing out. You'll notice that, you probably can't see this just with your eye. You might be able to. The connecting rod has become a little bit egg-shaped, meaning that this dimension from here to here is larger than the dimension from here to here. Obviously, that's not what we want. And you can tell that because when I put that on there, it's not raising the gauge any, but it's not excessively loose either. And when we get around to the side, you can see it is tighter because it is making our gauge wiggle there. Now, I've got a little piece of feeler gauge in there. It's a 3/1000 feeler gauge. And putting that in and measuring again, it's bringing us right up to our 0 point. So what we'll do is we're going to grind this mating surface of the connecting rod and the cap, and what that's going to do is make the bore smaller than it originally was. Now I'm going to do the same thing on the connecting rod. And there we have the same thing on the rod itself. Normally, and you'll see us do it on the other rods, we would put just a slight angle on both of them as well. That way when you torque it down together, that pulls the sides of the connecting rod in to make the sides smaller as well. Being that this one spun a bearing, I'm not going to do that because it's already somewhat egg-shaped.
I actually ended up taking more than I wanted to.
So knowing that I actually did cut more than enough off of these, for the rest of our connecting rods, I'm going to turn this down a little bit more. I was actually taking more material than I anticipated taking. That's not a bad thing in this case. It's not excessive, and it actually worked out being that this is a spun bearing. It'll just mean a little bit extra to hone out. That being said, on the rest of them, I'd like to keep it a little closer to that size, so I'm going to turn down this wheel a little bit so that we're not grinding quite as much off.
At this point, you can see me using the feeler gauge under one side of the connecting rod in an effort to cut the rod at a slight inward angle so that when the cap is torqued on, the sides of the connecting rod will be pulled in tighter as well.
One of the last things that I always do on these is deburr this edge because you will leave a sharp edge there after grinding the cap. It just takes a little touch just like that. Something that can happen in connecting rods is they can actually become a little bit magnetized over, thousands of miles of use in the engine. And I kind of noticed that on these connecting rods, and this will probably not be very easy to see, but they're attracting little pieces of metal filings. Obviously, we don't want that inside our engine because that just pulls all of those little pieces of bits of, metal in the engine and attracts them to the bearings. So the way we fix that, I've got our magnetic yoke here, and this is what we normally use for magnafluxing, but we can also use it to demagnetize these. So I'll just turn it on, and then we can pass this rod directly through the magnetic field. And that should demagnetize the rod.
I always use the ARP Ultra Torque Fastener Lubricant when pressing the bolts in, but I especially always use it on the threads of the bolt. It's specifically designed by ARP to provide consistent and precise fastener torque specifications, so it's really a great product to have on hand and to use when you're not only rebuilding the connecting rods, but when you're building the engine itself. Obviously, it's always super important to get the correct cap with the correct connecting rod, and that's why we numbered them when we took the engine apart, but sometimes you can't trust the numbers, as you might have seen in some of my previous videos, but in this case, the numbers that I stamped on the connecting rods didn't end up being the correct rod with the correct cap.
Now, ARP calls for these to be torqued to 50 foot-pounds, so that's what we're going to be doing here.
Typically in a high-performance application, ARP recommends using a bolt stretch gauge to measure clamping loads, as it is more reliable and consistent than using a torque wrench. As such, I did go ahead and check that our torque reading of 50 foot-pounds was putting us in the correct range of bolt stretch, and it was.
Our connecting rods back torqued together, when we measure them, we've got a little over 5 thousandths to take out there and closer to 2 there, so I'm still a little bit egg-shaped, but that's okay as long as there's enough material there to take out and get us to our correct clearance, to hit our tolerance, then we'll be good to go. So I've just started our honing with our rough stone. We're getting the connecting rods roughed out. This is that rod that spun a bearing. So you can see all those dark areas are the locations where basically the connecting rod is worn excessively from the bearing spinning. But it's looking like we're gonna have enough room to get that all cleaned up, so I'll show you the finished product here in a minute. See, we've just got barely any shadow there at the parting line. So this is cleaning up nicely. What we've been doing is roughing out the bores on our connecting rods. So I've got a coarse grain stone in here, and basically that's for bulk material removal, so that it removes the material quickly. That being said, you can think of it like sandpaper. It doesn't leave as nice of a finish. I mean, still plenty nice, but not as nice. But I've gone through all 8 of our connecting rods, and remember, 0 is our the tightest our connecting rods can be, and I've got them all within 4 to 5 tenths of being within our tolerance range there. So at that point, I'm gonna let these cool down, then we'll check the gauge, make sure everything is as it's supposed to be. I'm gonna grab some lunch, and then we'll put the fine stone in. We'll begin honing these back to our finished size within that 0 to 5 tenths tolerance that we have set here on our gauge. I've gone ahead, I've put in a finer stone. This is the rough stone that we were using. We're gonna put in a fine stone so that we can really sneak up on that final size that we want and hit the tolerance that we want. I'm gonna turn down the pressure a little bit. That's gonna make it machine a little bit nicer. So right there, you can see this leaves a nicer finish with the finish stone, and measuring, I'm right at the 2 to 3/10 past the minimum clearance that I want, and that puts me right where I want to be. I'm going to shoot to make all of them match exactly the same. Now with the rod's finish tone, I checked the gauge one more time, made sure that it was set correctly, and just double checking here. We're right at that 2/10 past our minimum clearance there. Kind of in that 2/10 to 3/10 range. That's what we were shooting for. If I find any that are tight, for instance, this one maybe seems a little bit tight after cooling down, I'll go through and I'll just touch them just barely a little bit. Now this isn't the final wash on these parts, but for now I'm just going to rinse them off here in the solvent. I believe we are going to be balancing this assembly, so I'm going to leave the rods together for now. So that's basically the process for resizing these connecting rods. Again, we have the ARP bolts in them. This isn't a performance application, it's just those are literally the only bolts that we could find from any of our suppliers for a 350 Pontiac right now. That being said, you know, we were able to go through, one of these rods did have a spun rod bearing like we said, but it really wasn't too bad. It was able to come out, clean up just the same. I took a little bit more material off of that one, and looking at them, you really would have no idea which one it was, other than I know it was this connecting rod, and based on the weight, if I can get changed over to grams, I'll go ahead and zero off of that connecting rod, and then we'll go through and check all the rest. 7 grams heavier, 4 or 5 grams heavier overall, 8 grams heavier overall, 4 grams heavier overall, 8 grams heavier overall, 8 grams heavier, and 8 grams heavier, 7 grams heavier. So that's really the only way that you would even know which one had a spun rod bearing, because we had to grind a little bit of more material out to make that bore smaller, and then hone a little more material out to make it clean up the way that it has. But like I said, if you did not know, you know, you would never really be able to tell that this had ever had a spun rod bearing. And obviously we're confident in it. We wouldn't use it in our customer's engine if we weren't confident. We have all kinds of coarse connecting rods, so if we weren't confident in it, there would be no reason to. But from here, we are going to be doing a balance job on this rotating assembly in a later video. But that's how we do the connecting rods. From here, I'm going to get going on this block. I need to get it cleaned up. Well, it's already cleaned up. I need to get it mounted here on the machine so that we can go through, deck the block, square up the decks, and bore the cylinders. So that'll probably be the next video in the series, so stay tuned.